So now that we have done chapter 1, which is kinematics, so just describing motion, what is the acceleration, how fast something is going, how long it took, we move on to the second part, which is dynamic. It's Newton's law, explaining how things are working. We call that dynamic. We're now in the third part of the first unit, which is still describing motion, but it's mainly talking about circular motion, things that are going in a circle. Okay, you will find that later on, like when we're going to be dealing with things that are going in a circle, we usually need the radius of the circle, how fast it's traveling. And the key thing that you keep in mind is the direction of acceleration. Yes, it is accelerating, because for things that are accelerating, it has to have a change in velocity. But then you'll be like, if I'm spinning a circle with a speed of 10 meters per second, how come I am changing speed? Well, the reason for that is the direction will be changed. That means there is going to be an acceleration. And keep in mind that acceleration is always pointing into center of the circle. And we use a little prefix to go see. So, and then we're going to tie it into the Newton's law. When things are going in a circle, we still do worry about F net equals to MA. But this time the A, instead of using like the high five to solve for it, or linear acceleration, we now have a circular acceleration, which we will learn today how to find it. Okay, so we're going to be dealing with circular motions, and we're dealing with circular motion that we assume that it has a constant speed along a circular path with a constant radius. Okay, and it is going through a velocity change because of the changing direction. We have learned this thing called changing velocity. So I'm going to start this. I don't know if you recall, but we said that to find out v2 minus v1, what we do is, in terms of drawing vector, it's like adding the negative. Okay, imagine that if I have an object and I'm telling you the object is spinning at 10 meters per second the whole time at a constant radius. So the object is spinning, and there are snapshots of time that we're going to be looking at. The first point we're going to look at is this. Okay, the velocity right now is going upward. Imagine I'm going this way. Okay, so counterclockwise. So this is v1. Velocity 1 is going upwards. We're talking about the tangential, like the tangent speed. Right at that time, if I let go of my hand, does it make sense that it's going to be spinning up towards the up? Like if I snap like the string or something. This is hooked up to a string, and if I snap it, it's going to be going upwards, right? How about if I look at this point? Okay, which way would the speed be going? I'm spinning it counterclockwise, right? At point A, it is going upwards. At point B, which way would it be going? So it's spinning, and at point B, V2 should be here. I'm calling this V2 because this is later on in time. Okay, to figure out what is the acceleration, I'm going to be using V2 minus V1. V2 looks like this. Minus V1 is the same thing as adding a negative v1. Okay, so meaning from this point, I can draw a negative v1, which v1 is going up, meaning a negative v1 will be going downwards, right? So I'm going to be drawing it downwards. So if I ask you, what is the change in velocity with this? Change in velocity is basically starting point to ending point. So at this point, change in velocity between point A and B points kind of that way. See how it's already slightly towards the center of the circle. So then if I say, there is a done picture here. You don't have to draw it, like they're just trying to explain it. If we look at this, as we approach time equals to 0. So what that means is, instead of going point A and B, how about if I say I am decreasing the delta t? I'm trying to bring the time interval closer together. How about if I say right here, if I call this point C and I compare A to C, C would be traveling that way, right? So this is V3. Okay, if I were to calculate delta V, the change in velocity, it's going to be V3. I'm going to compare it to V1 minus V3. Okay, the vector symbol, I mean V1, right? Okay, draw the picture. V3 goes this way. This is V3. Adding the negative V1. We already established the V1, which is going downward. Do you see how we're pointing this way? This is now delta V. Okay, as the interval get closer and closer together. So this is the start. This is the startup. Okay, this is point A and point B. And then they said, how about if it's point A but closer? Like as you move V2 closer and closer, you would see that the direction is always pointing to the center of the circle. So what they're trying to prove to you is acceleration in a circle is always pointing towards the center of the circle. Circular motions, Ferris wheels, roller coaster, planetary motion, electrons orbiting and atoms, all these apply to that. And the equation, it's AC, so acceleration in a circle, centripetal acceleration, that's what we call it. It's V squared over R. V squared, V for the speed, and R is the radius of the circle. Okay, and then adding on top now, you can have other information that can help you figure out what is the speed, what is the radius. Okay, so this goes back to definitions. Okay, so we know that speed is distance over time. Notice I'm not using velocity anymore. We're now talking about speed because the speed keeps changing, right? Like your direction keeps changing. Speed is distance over time. If I think about a circle, okay, if this is my starting point, how far would a circle travel? Like if this is a dot, it makes one circle. The distance that it travels, it's actually the circumference of the circle. And the equation for circumference of a circle is 2 pi r. That is d. Okay? How long does it take for one circle? We use a term called capital T. We said that this is period, meaning the time it takes for one cycle. You would have learned that in grade 11, or maybe not. It depends if you have it at semester 1 or 2. Your teacher might have had to cut it out because of time. The time it takes for one cycle. Okay, so it's a definition thing, and we're gonna use capital T as a symbol. So if I were to sub these two into the equation, speed is distance over time. The speed of the circle is going to equals to the circumference, so the length of the whole circle divided by the time it takes for one circle. Okay, so this just kind of added an extra thing. So this is another equation that you would need to know. Okay, so this is the explaining of it. Capital T is the period, the time requires to complete one cycle. Okay, and you got delta D is T, they sub it in 2 pi r. And so if I were to attach it to the AC equation, centripetal equation is V squared over R. But sometimes they don't directly give you speed. They'll be like, oh, the radius of the circle is this, but it takes this long. Then what you do is you can actually plug in 2 pi r over T into the V squared, all divided by the R. So 2 pi RT is 4 pi square R square over T square. I expand out the T and then I have the R at the bottom. So I don't know how good you are with dividing. So if you wanted to make sure you're dividing this right, so this and this is the same thing. Like, so all I did is I rewrote the top term and divided by the R. When I'm dividing something, it's like multiplying the reciprocal. So that means R is actually at the bottom. So that means this square and this R cancel each other. 4 pi square R over T square. So if I combine the two equations, the centripetal equation and the equation for speed, if I join these two together, this is your new equation. Okay, so I'm going to rewrite this out. AC is 4 pi square R over T. And finally, one extra definition is period is also equals to 1 over frequency. Okay, so what that means is I also could have written out, oh sorry, I missed a square. Okay, I could have written out that this is A, this is 4 pi square r instead of t squared at the bottom. Because t equals to the inverse of the f, I can bring the f at the top. So just combination, depending on what they give you in the question, these are choices that you can have, okay? So be like, okay, let's rewrite all the equation out so I have them all available. I know AC is v squared over r. I also know that v is 2 pi r over t. Combining the two, AC can be 4 pi square r over t square, or okay, so a car turns a circular curve at a speed of 20. If the radius is 100, calculate centripetal acceleration. So they give you speed and they give you radius and they're asking for AC. So we wrote the equation out on the side. So it will be the first equation that we're using. So 20 squared over 100. So punch it in your calculator. Have you guys been doing that, or do you guys just write out whatever I write out? It's a good idea to look at it and try it, okay? Meters per second, and what you say is in. The direction is in the center of the circle, so I just write in. Next one, a ball swing in a horizontal circle with a radius of 2. If the centripetal acceleration is 15, what is the speed? So radius is 2, acceleration is 15, and it's AC. What is the speed? So I use the same equation. So 15 is v squared over r. So 15 times 2, and then take the square root. So v is 5.5 meters per second. And there's no direction because it's constantly changing. What is the centripetal acceleration of a stone being whirled in a circle at the end of the 1.5? At the end of the string, this means the radius, right? The frequency, now we're moving on to the other equation. So they tell you frequency is 1.25. So what do I have? I have radius is 1.5, and they tell me the frequency is 1.25 hertz. Hertz means inverse of a second. And they want AC. So go back to all these equations. Do you see how if there's a frequency, I use the last equation? So AC is equals to 4 pi square RF square. So 4 pi square R is 1.5. F square is 1.25 square. Can you not use 3.14 for pi? Can you use the pi button that is in your calculator? Find it somewhere. Use that. Don't use 3.14. Okay, so 92.5. So 266. So 93 meters per second square in. Okay, these are just pretty simple. But get used to how to do the, punching in the calculator and stuff. The planet Mercury is moving approximately in a circular path around the sun with an average distance of 5.8 times 10 to the 10 meters. That's your radius again. And it is accelerating centripetally at 0.04 meters per second square. What is the period? So they're looking for t. So how long does it take for Mercury to go around the sun? That's what they're asking you. Okay, so average distance is 5.8. Does it make sense that that's the radius? So if this is the sun and the average distance of Mercury and it goes around the sun, does it make sense that that is the radius of the orbital the orbits? Okay, it gives you AC is 0.04 meters per second square. They would like you to find period. So go back and find the equation that has the period. So this lesson is fairly straightforward in terms of math. You need to know your equation. So AC is 4 pi square R over T square. So t is what I'm looking for. So I guess the only trick is, can you rearrange the equation properly? So I got 0.04 equals 4 pi square r. Oops, I'm not going to put the meters. Okay. All divided by t squared. Unknown is at the bottom. And I don't know if we talked about this. The easiest thing to do is swap them so that now t squared is at the top. And then now you have the other guys. The 0.4 is now going to be at the bottom. Okay, now you're going to punch it in the calculator. Do you know how to type in scientific, scientific notation? You take the times 10 and you replaced it with the EXP button that is on your calculator. Okay, so you would go 4 times pi square times 5.8 EXP 10 divided by 0.04. And then you would need to take the square root of that because that t, but we were calculating t squared. So t after the square root, okay, the humongous number, I got something like that. Okay, you put it back into scientific notation with 1 sig. Oh yeah, this is horrible, it's 1 sig. So I have 8 times 10 to the 6 seconds.